Well, I hope that doesn't flash the entire time over here for you. Sync your eyelids. Okay, I want to start off talking a little bit about the project, questions people had, things that have come up. Number one, I think that's maybe a little bit confusing. I told you to use our basic solution of the producer-consumer one that I had in the notes. There's a couple of big differences between what we were doing there and what we're doing here, however. The first one is that in that example in the notes, both the producer-consumer threads were in counted loops. And we knew exactly how many times the threads were going to run. You can't do that in this case because what you have is, in the case, for example, where a withdrawal thread goes to sleep, waiting for a depositor to put money in. If the depositor finishes a counted loop before the withdrawal thread is signaled, nobody's ever going to signal it. In other words, you've got a withdrawal thread setting up here, never going to resume activity. So they have to be in infinite loops for the give and take. Second thing is, in that one of the notes, the signaling was in both directions. The producer was signaling, the consumer was signaling when the buffer was empty or full. Here, the depositor is never blocked. Okay, so there's nothing that a withdrawal is going to do to signal them to unblock them. The only blocking threads are the withdrawal threads, and they only block when they go to the account and find that there's not enough money in there for them to withdraw. Okay, then they block, and they're waiting for the depositor to signal them. You have a question?
Yeah. When you talk about programming the notes, you mean the one first?
The producer-consumer problem, yeah, the one with the synchronized buffer and all of that.
Yeah.
So that's a big difference there. Also, in the producer-consumer one of the notes, we had to basically allow either of the threads that when they got the buffer, they had to know whether the value that was in the buffer was one that they had already seen or not. Because we wanted them to just see each value one time. So they read their integers in sequence. They read each integer once and only once. Here we don't have to worry about that variable. When a thread, whether it's a producer or consumer thread, when it gets access to the bank account, it can do its job. Okay? So a producer will just, a depositor will just put money in. It doesn't matter how much is there, it's just going to add money. A withdrawal thread has to check the balance to see whether or not the amount it wants to withdraw is more than what's in it, in which case it blocks. But otherwise, it just takes the money in. Okay, so it doesn't have to look and see, is it valid in that sense. So that in some way simplifies what was going on inside the run methods. But the biggest difference here, of course, is that the signaling is only one direction. Okay. Any other kind of questions anybody has on that? What I would suggest you do is you start things out and try to get things, the synchronization correct. Just start one depositor and one withdrawal. Just like the producer-consumer problem. You just have one of each thread running, it's a little bit easier to see what's going on. Okay? And then once you know that that signaling is back and forth correct, what would happen again was the depositor would just sleep, the withdrawal thread will run, it'll bleed down, it'll eventually block itself because there's not enough money, and then it'll basically wait for the depositor to wake up, put some more money in, the signal, you can see it start up again, and then you can continue. Once you've got that working, you can just dump the threads, all the threads that you need to run.
Just regarding spacing on regarding spacing on the console, I ran into the issue of like when I use like spaces, just or just tabs, it comes out a little skew, and I was just wondering if there was like
I just did it with tabs.
just tabs.
Yeah, I just used tabs.
Okay.
I don't know, it might look a little sloppy, you know, when it gets down here like this sort of thing, but,
Right. was
I
wondering-
just had basically to get into the 3 columns is all.
Okay.
That's fine. If you want to, and this is a perfect application for that to work, rather than just having it go to the console, you can just redirect the output to a text file. You can format it maybe a little bit better than just double text file.
I almost love to do that because I'm using that 8 so one console is pretty small.
Yeah.
So I can always have.
Yeah, if you want to dump it off to it, you know, just redirect the output to a file, that's fine. It doesn't have to be console screenshot.
Okay.
Anything else anybody can think of? Huh?
Just to clarify, when a thread is blocked and then it runs back up again, it doesn't have to it doesn't have to withdraw that same amount of money.
No, you could have
Okay.
it regenerate the
Okay.
amount of money it's gonna do. If you wanna save it, that's fine too, but there's no real need for
Okay.
it.
And we can use the re-entrant lock in Java?
Yes, yeah, you
Okay.
can do that. You don't, the reentrant lock is fine, the only thing is the fairness policy is gonna maybe, you know, if there were lots of, like, slow things down a little bit.
Gotcha.
In this case, we set all priorities the same, so it doesn't really have much effect.
Okay,
Anything else anybody can think of? Okay, well, I'm gonna actually push the due date for this back, until a week from today. Okay, it's actually due right now on Sunday night, but I'm gonna push it till a week from today. Okay, when I get back to the office, I'll make that change over the courses. So I'll give you, 3 extra days to work on this. Okay, the next thing I want to go over is, again, something I went over a little bit last time, which was, we started looking, of course, at JDBC. And JDBC is essentially the connectivity of a Java application to a database on the back end. I showed you how to set up a MySQL server, so that's basically the databases that we're going to be using throughout the semester. Again, it works on any kind of commercial database system. All of them provide drivers for Java and other application languages, as we'll see when we get later on when we do, for example, PHP into the MySQL. But so some of this stuff that you're seeing in here, if I go back to this point, something right here. These 2 strings particularly, again, that's peculiar to a MySQL database. If you're using an Oracle database or SQL Server database, those strings look a little bit different. So you're loading a different driver, the URLs are specified a little bit differently. So you have to, of course, handle that in the application, but that's again just the kind of database you're connecting to. The next thing we looked at was dealing, of course, with the metadata. And this is something that's going to be universal. You're not going to really generate much of an application without dealing with the metadata side of things as well. So when you pull a result set down, you can also deal with the metadata that belongs or goes along with that result set. And that, of course, is what I've done here. Now, most of the applications that we're going to be starting to get into, of course, from an enterprise application point of view, 2-tier, multi-tier applications, the user front end is going to be some sort of a GUI. You're not going to give the user a command line front end for this kind of an application. So several things are going to happen here in the user front end that at this point we're kind of glossing over. For example, in this particular application here, when it comes up, the user is already connected to the database. Okay, they're ready to type a query or in this case, a query into the command window. So the login has already been done to the database. That connection is established. So here we're making the assumption that it's a root user, and they have all permissions. They can do anything they want. So no query would be blocked to a user from this particular application. As we get into more complex cases, and what you're going to see, for example, in your next project, is that you actually have to deal with the client connection, because the clients don't always have the same kind of permissions as the root users. In fact, generally they have a very, very restricted set of permissions. So the first thing that would happen is there's going to have to be that connection established based on whatever user or client credentials that they're going to supply. I have already put that into this application. That's the root that's in there. So we're not gonna be able to hard code that in. We're gonna actually have to ask the user for their credentials, and then once that connection is established, as they go back and forth, you can mimic that a little bit on your MySQL workbench, the application table of MySQL. And what we're going to have to do in the next project is you're going to create a client, and you're going to set some permissions on that client. But you can go ahead and do that yourself and play around in the workbench. We're going to do it from our application point of view. We're going to create the client via the workbench and set their permissions there. But essentially what you can do is create a connection then with different credentials, and what we'll see is the client won't necessarily be able to do everything, only what you provided them. So the important part about this is that this result set table model class that I put out there for you, it's a very versatile class in the sense that what it's doing for you is it's handling all of this. Okay? Everything in the bottom half of this particular GUI is being provided by the result set table model class. So we've just got a GUI here with a window in it that we're dumping a result set into, and the result set is handling all of that. But it also is handling the connection. It's also handling the errors and anything that might be generated on that side of things. So for example, when you look back here in the result set table class, what might happen here, for example, is when you try to make the connection, remember one of the things that we said there before was if you don't have the driver loaded, you don't have the driver where the driver manager can find it, it throws a class not found exception because it can't find the driver class. If something else goes wrong on the connection, in other words, the driver load's fine, but then maybe the client credentials are wrong or something of that sort, what you're going to get is generally a connection violation. That is, the database will not allow you a connection, and that error is going to be something different. So you'll notice in these kind of cases that I generally throw these kind of exceptions, and the reason for that is that very often we don't necessarily want to handle that connection or handle that error where it occurs. We want to pass it off to some kind of a general error handling class. So when you were developing your Java applications in the O or whatever, 3330, did you deal with throwing exceptions and throwing them off to other classes and let them deal with all the problems? Because we don't want to deal with that here. Okay, that's a completely separate issue as far as the errors are concerned. But we will be dealing with it as a point. So we'll probably have a completely separate class that's doing all of that. Now, the last thing we were going over last time, I went over it kind of quick there with the class, is when you start dealing with enterprise solutions and your clients, your users of your application, they're going to vary across the board in terms of what skills and capabilities they have. One of the things that enterprise distributed applications basically mean is that the entire organization, the way it is using and accessing its data is coming from these different applications that kind of define what the enterprise is. So some of the users are people who work for the organization, the database administrator, for example. All these people who know all of the details about their data, what's going to be, how it's being used, what's there, ranging all the way to a completely naive client who's just coming to the site to maybe see what you can provide them. If it's an e-commerce oriented site, maybe they're just browsing your products. They have no intention of buying. Some of them might have intentions to buy. But the point is, you're going to have a very wide variety of skills of the users, and your interfaces, the way the different applications are going to be providing those interfaces for those users are going to be very different. So in this case, for example, this might be an interface that the database administrator is using of that sort. In other words, they can type in a query, they know SQL, they know what the schemas of the databases look like. Your clients that are going to just kind of browse the products, they have no idea that there's a database there, what's in those tables, what any of that actually means. So their interface is going to be completely different. And one of those differences might be in the sense that you provide them a little form. And the form would basically have some input data to say, what kind of products do you want to look for? You might, categorize them for them. You might break them down by price or color or availability. But you have a form, and the form is essentially going to provide the data of what the client is interested in. And then you want to convert that data that's in that form into, say, a query on the database. Well, that again has to be provided through the application. And since you don't know what the client is interested in a specific sense, you have to provide a way for them to provide that data to you, and then you generate a query based on the kind of things they're doing. And that's where this prepared statement interface really comes into play. The SQL statements that are actually part of this, this whole interface that you're going to provide the user, they're already pre-compiled, they're already loaded and ready to go. All you have to do is basically provide the parameters to them. So once the user enters that data into the form, and again, that form data, say here in this case, if it's a data entry screen where somebody's going to add, say, new products to your database, again, the person who's adding those new products doesn't need to know SQL. They don't need to write an insert statement. They don't need to know what the schema details are and so on. So you simply provide them a form that asks for, in this case, these 6 pieces of information. Now on the form, the input form, one of the things that you have to be careful about, again, going back to the case of this, if you remember when I gave you the little script to generate all this byte database, the byte name was the key field, okay? And then we had, for example, the cost. Cost was an integer field in that schema when we built it up. Now, on the input form that the client is filling out, suppose that they were to enter a byte name for a byte that already existed. It's already in the database. If they did that and then clicked go or whatever, what would happen on the database side when that insert command was actually executed? It would fail, right? Because we'd have a duplicate key. Okay, we can't put the same key field in the same table more than once. So we have a duplicate key field value that would cause an error. On our input side, the user is now going to see, oh, we've already got that record in there. So this is one field here where, unfortunately, when we try to validate the data that the client's putting in the form, we don't have any way of validating that until we actually run the insert. Okay? The only way we could do that would be to actually, first of all, just extract the byte name out of their form and then run a query to see if that already existed. That's too much work. Okay? So in this case, if they actually put in a duplicate byte name, we would go ahead and send that across. We can't validate that, in other words. And then the database would kick it back on an error. And then we would tell the person, sorry, that name's already chosen. You've got to use it and come up with a new name. On the other hand, if we were, say, talking about this cost field, we know that's an integer. And we might have some constraints on that particular value. In other words, maybe the cost has to be between $500 and $15,000. Okay, if they were to then type in any value inside that range, we'd say, okay, it's fine, you meet the criteria. But if they were to type in 20,000, we could catch that on the form, on the front end side, say, sorry, that's out of range, okay? Because we know what the range would be. So some of the data that's going into this can be caught, we can validate it right up front, but some of it can't. Generally, anything that's key-based, we would not be able to do that for. We would have to actually allow the database to kick it back on an error. Only the database would actually be able to know. But for normal kind of integrity constraints that exist on the data, you can check those up front, and you should. Because if you don't, you're going to spend a lot of back and forth telling the user, no, this is wrong, and you really shouldn't do that. So you want to validate that kind of data up front. But again, the point being here, in this case, the little example I gave, the user enters the bike name here, and then they click the button, and what I'm doing with the prepared statement is I'm simply putting this name, again, this is a very simple form, I'm just extracting that name and putting it into the query. So here is the form field I'm grabbing out of, the data field I'm grabbing out of the form, and then I'm just generating the query on that case to actually generate the results to show the user how much that bike costs. What would be a better way to do this in this case? Can you think of a better way to do this than have me type the name? I want to put a drop-down list that would be in there that would list all the bikes, so you can just click the bike you want. What would I have to do to generate that drop-down list for you? I would have to run a query for you. Select bike name from this table and just generate that list. Okay, so one of the things that we're going to be seeing a lot of is that as we go deeper into these, the use of the result set, the use of the enterprise application, one of the things you're going to see is that not only the SQL command that the user wants to run is going to be the only thing that runs. We might have a lot of background queries, a lot of background updates that are being run because of what the user wants. Again, an example would be if you go shopping on Amazon and you want to look for certain products. As you're searching for those products, what's basically happening in the background is queries are being run. And queries to generate or go through the data sets and find that data that you're looking for so you can see it. Once you get to that point, you select a particular item, so okay, I want to put that in my shopping cart. What that will now do is do an update on the database. Again, you don't do the update, but it's done to now show that that's in your shopping cart. Also will update your shopping cart, which is also going to be a file, a database table. And then when you actually check out and actually purchase the product, the actual database table also have to be updated to reflect that you now have one less or how many ever that you bought of that particular product. So there'll be lots of database operations going on in the background for a single, perhaps a single action that the user provides. Taken as a whole, that's called a transaction. And so when I've mentioned several times about a transactional database. The transaction is basically the all-encompassing aspect of what the user's doing on your database from start to finish. And in general, there's many queries, many updates being run for that particular transaction. And a transactional database, like we were talking about, you're going to set up in MySQL, is the row safe level locking. So a transaction can get a lock on a row in the table at a time. Now, as the transactions are proceeding, again, in a normal kind of environment, it's all multi-threaded. So you have lots of transactions doing similar sorts of things to the database. This leads us into other types of connections to the database. Now, the ones that we've set up thus far, when we got a connection to the database, we held on to that connection. Again, from the database point of view, what the connection is, there's a thread pool of connections available on the MySQL server. When you want a connection, it gives you one of those. It dedicates that thread, that connection to your application as long as you want to keep it going. When you ultimately close the connection, that returns that connection thread to the pool on the database server side. But as long as you remain connected and keep doing something, that connection is yours. Here we move into more enterprise-oriented types of interfaces where while the transaction is processing, it does not necessarily remain connected to the database. So you'll connect to the database, you'll bring some data down, you will disconnect, do something probably operationally on your application side, and then you'll want to reconnect to the database, do some more, grab some more data, upload some data, whatever it is you might be doing. And then you'll, again, come back and do some processing on the application side. The point being is you do not want to keep the connection to the database tied up over that entire period. So you connect, release, and first one of those types is called row set. Now, there's various types of row set implementations. It is part of the Java standard edition, or the row set interfaces you can do in standard edition Java. However, it's much more applicable in an enterprise version, the JEE versions, which we're going to be getting into later in the semester. But I'm introducing it here now so you're kind of aware that they exist. You'll see them much more later on when we actually get into the enterprise and transactional-based processing. There are basically two types of row sets. There are disconnected and connected. A connected one is very similar to the one we've just been dealing with. It is a different type. We'll talk about the reasons for that later. But the disconnected one is the one I was just kind of mentioning. You connect and reconnect. It allows you to modify data in the application on the application side and then reconnect to the database for uploads after you've done that processing. It does require a reconnection. That is, you have to get a new connection. It's not like it holds your connection in reserve or anything. It's a brand new connection at that point. Now, within the row set interface, there are several different types of sub-interfaces, which again are very important for enterprise type applications. The JDBC row set, the cached row set, and then there's actually a couple more that I'll talk about a little bit later. But the JDBC row set is a connected row set. It's essentially a wrapper around a result set. And it always allows scrollable and updatable result sets. So you cannot set it unscrollable, you cannot set it uneditable in this case. So that's a change in that sense, in the type of default result set that it operates around. A cached row set is, again, a disconnected one, and it requires some, it is scrollable, it is updatable, and it's also a serializable interface. So it implements a serializable interface, and it means you can actually pass the connection between different applications. This is an important aspect in many enterprise solutions because when you think about, again, a very large type of application, when you are, say, buying something from Amazon, how many different databases do you suppose you are connected with while you are dealing with that operation? Way more than one, okay? Think about going down here to Disney and you want to get some fast passes, you want to get a dinner reservation, a hotel reservation. That stuff is not all in a single database. It's in multiple databases. So the transaction is processed across multiple databases, some of which you're connected to in a moment, others you have to connect to on the fly, dynamic connections. So there's a little bit to deal with, how much data is going to come across on a given command that you might have processing in your transaction. So a cached row set, the limitation on it, of course, is the amount of data that you can bring down in cache. You don't have an unlimited amount of cache. It does not allow you to have, in other words, you are using your cache. You're not allowed to use a file for this. So you don't have unlimited storage for the cache. What people have tried in the past is to cache an entire database. It won't work that way. You never have enough room for that. There are also three other sub-interfaces in this interface, which are, again, very important from a point of view of how you're accessing the data. The filtered row set, the web row set, and probably the most important one, the join row set. As you're going to see when we go into the full enterprise application, the database that we're connecting to, even if we're talking about a single database, that single database is generally not in just a single physical location. The data itself is distributed geographically. Often databases are distributed simply because you put data closest to where it's going to be used most frequently. So for example, In the sense where, if you think about Disney reservation systems, and we'll just consider ourselves two parks here, the ones in Florida, the ones in California. The hotels to make a reservation in California and the hotel reservations in Florida are in separate databases, okay? The ones in California, primary location, are in California. The ones for Florida are primary location in Florida. Why do they do that?
Access time?
Exactly. Who's going to make most of the reservations for the Florida site? People in the Florida offices. Okay. Put their data right here. It's local. It's very fast access. We don't have to send things back and forth across the country. Sometimes, however, somebody here will want to make a reservation for one of the California hotels, so we can still access it, but it's probably going to take them a little bit longer to do that just because of the network lag. So the data is distributed. Now, we can also distribute that data. Let's look at the case where we have the data for the hotel here. Is there a single instance of that database? Would Disney have just one database for their hotel, say for the Grand Floridian?
No.
No, there's going to be replicas of that. They want to have backups. They have to have fail-safe built into that. So if you make a reservation in a Grand Floridian here, and you get that reservation entered into the database, it's now going to be replicated in several different databases around the country, different sites where they have their replica backup areas. Now, suppose that you cancel the reservation. Okay, you discover how much it's going to cost you to spend the night there. And you cancel it. Okay, now you cancel, you call them and say, I want to cancel that reservation. They're going to delete it from the database here in Florida. They also have to delete it from the databases that it was replicated into around the country, wherever those might be. Okay, now, the question is, as I start to do that, obviously the database you can switch from one database to another anytime. And again, in a failover operation like that, that's generally what is being done. The databases are all kept online and active, so that any moment in time I can switch from one to another, and I don't see really any difference. So they have to be kept consistent, they have to be kept up to date. So if I delete it from here in Florida and say I've got a backup in New York, I've got to go delete it in New York. I do have a little bit of lag time that I can handle there. But suppose that as you're deleting the reservation in Florida, somebody is attempting to make a reservation for the same hotel. Suppose you have the very last room. And the delete that you are making has not been completed in Florida. So when the person tries to make the reservation, they're going to get a sorry, we're all full. Okay? Now they delete that one in Florida, and suppose that somebody else in another site is again now trying to make a reservation at that hotel, but as they connect to the one in New York. What do they see? Do they see an availability, or do they see that it's all full? They see that it's still full until the data, the deletion has been replicated in the New York site. Okay? Now the question becomes, how long does that take? And more importantly, when do I have to do it? So there's a thing when you have replicated data like this, that if I, in a general sense, if I make some transaction on the database and I need to replicate that across the copies, if I do the replication too quickly, too rapidly, I may do extra work than what I really needed to do. And the case in point for that would be the hotel reservation that you just deleted in Florida. Before you deleted it in New York, somebody in Florida grabbed that room. Okay. Now, if I have already gone around the network and made the fact known that you deleted that reservation, as soon as somebody grabs the one from Orlando, I now have to re-replicate the fact that it's now again not available in all the sites. So if I do the replication too rapidly, I probably have to do extra work. If I wait a bit, I may not have to do anything at all. The case in point would be, I wouldn't have to update the New York site. It's still deleted. It's not available. If I wait too long, then I'm gonna get a bunch of people trying to make reservations and they can't do it. In other words, I'm unnecessarily delaying. The filtered row set is a way to deal with that connection where the filter is a query that you're putting up. I want to know something about the data. Does it meet this criteria? Does it not meet this criteria? So in addition to the connection is only going to allow me to connect to rows that match what I'm actually filtering. The join row set gets even more complicated. When you were in your database course, this is something that they don't often talk about in 2545. Did you discuss the same operation? Doesn't sound familiar. You discussed joins, right? Joins are where you have to combine data from more than one table to get the combination of data you need. A semi-join is well, back up. Suppose I'm going to join table A and table B, and they're in two distinct sites in the world, two different locations. What do I have to do to join table A and table B together? Suppose I want to do the processing at the place where table A is, just to make it simple. Well, in a general sense, I would have to move the data from table B to table A and do the join. Okay? Now, if you remember something about the join properties, the most common join, or the most frequent join that you do is a natural join. And a natural join occurs only on commonly named attributes, primarily the key. That's the most common kind of join. So if I'm going to look at a table over here at site A, and suppose there's 100,000 rows in this table, and suppose there's 100,000 rows in table B, and I'm going to join them. Okay, and I'm going to do a natural join based on a key. What is the maximum number of rows from table B that I need to bring across to site A to get them to join? One. Okay? Key can only occur at one spot in that table. So if I'm joining on a key, there's only one row out of this entire table that's going to match this one. Okay? Do I want to pull 100,000 rows over to find one row? Not across the network, I don't. I want to bring up one row. So what a join row set does is it looks at the join criteria on the site where the operation is going to occur, and it only pulls the data out of the table that's going to participate in the join to move it across the network. That's the simple case. More often than not, where I'm going to do the processing is not in either of the sites where the data is. I'm going to do it in a third site. So now I have to look and see and bring across two pieces of data from two remote sites, and I only want to bring in what's going to join. I don't want to bring in extraneous data that just ties up too much network traffic, moving data around. I just want to bring things that I actually count. And that's where the join row set comes into play. Now what I did here, just to have an example of this, is I used the row set. The one I used up here is the JDBC row set implementation. This is a Sun proprietary implementation. What that normally means is, for example, if you're running an Eclipse, the library that it's part of would be considered a foreign access. By default, Eclipse will generate foreign access requirements as an error. You have to set your warnings and errors for foreign references to either ignore them or just flag a warning on that if you want this one to run. Okay? So you'll have to do that. I just did the same sort of thing I did before. I just did a simple query on the byte database. The only difference in here that at all is I'm using the row set implementation rather than the result sets and things that we, or the normal connection we were using before. So when it executes, you don't see any difference from it. So the point here being is that all of these extraneous interfaces for a normal standard single site small database, you're not going to gain anything. Their benefit all comes into play when you're dealing with distributed enterprise database systems, and that's where we're going to be headed a little bit later in the course. But I put that in here because, again, it is all part of JDBC and the way you're going to be accessing the databases as we get deeper into the course. So that's the end of the JDBC stuff. What we're going to start looking at next time will be the 3-tier or multi-tier applications. So we're going to move all of our application logic onto a web server. We're going to start out with a specific technology which is called servlets, Java-based technology. So what we need is a servlet container, a servlet engine, and the definitive one for that is Tomcat. So I will show you how to install a Tomcat server on your local host system. You'll get it up and running. And then while we're doing all that kind of stuff, talking about servlets, you're going to be developing a 2-tier application using JDBC and MySQL. I'll give you that probably on Monday. Okay? Project 2 delayed till Wednesday. Project 3 will probably come out on Monday anyway, but you got a couple extra days. See you then on Monday. Oh, there should be, one of the TAs should be here on Friday.